This is Brent with Lykins Motorsports, and was it last week? I think we started a series on basic engine building techniques and theory and all that stuff. And this week I wanted to build on that by going over piston compression height and rod length, and thinking outside of the box on a given engine build. And the reason why I decided to do that today was I got this piston rod assembly in for a Ford 289 build that I'm doing for a customer for a Shelby 289 Cobra build. And we are building this engine as numbers matching and period correct on the outside that we can possibly get it. And on the inside, we're going to employ a whole lot of new age engine technology and building techniques. So that would include roller cams and Malle pistons, and with a modern ring pack and that sort of thing. So this is a piston for a Ford 393 Windsor, which is a stroke 351 Windsor. So if you're wondering how in the world can Brent use a piston that's for a 393 Windsor, which is a 9500 deck, how can he use a piston for that in a Ford 289, which is an 8200 deck, and the stroke is different and everything else? Well, we're going to go over that right now. So for any given engine combination, you have a block deck height. And the deck height is, the definition of a deck height is from the center line of the main to the top of your block deck. So if you think of a traditional V8, and I'm going to turn it upright, and this is your cylinder, okay? I'm not an artist, keep that in mind. We will say that this is your crankshaft center line, okay? So your rod throw would be somewhere maybe around in here, and you would have a connecting rod with a little end, and then you have your piston, okay? There's your wrist pin. Very crude, I know. So deck heights, actually that should be down here. Your deck height varies depending on what block you're using. A Ford 289 or Ford 302 is generally listed as 8206. A 351 Windsor, as we mentioned, is 9500. A 351 Cleveland is 9200. An FE is 10170. And we'll come back to this. Early Windsors were actually also 9480. Your 385 series stuff, like your 429, 460, they had a couple. 10320 is pretty common, but that is, again, the measurement from the center line of the crankshaft to the top of the block deck. That is your constraint. That is the amount of distance that you have to fit a connecting rod, a piston, and by definition, half your stroke. So when you think of it that way, and you think, okay, I've got so much room, and I've got half stroke, and I've got my rod length, and I've got my piston compression height, that's going to equal block deck height. Now, in this particular build, I am using a 289 block. Like I said, from the factory, they're kind of listed as 8206. I've seen those all over the place, and they generally are, because factory blocks are not known for machining tight tolerances, and sometimes they're out 20 thousandths from front to back, and sometimes they're a whopper-jawed mess. So what I do is I have my 289 and 302 blocks generally machined to 8185 to 8190, and that generally gives me enough room to counter any bad machining techniques that the factory had back in the day. So for this particular build, we're going to use, let's do this first. We'll take the factory block deck height as listed, and let's look at a factory 289 piston compression height. So half the stroke, a 289 stroke is 2.87. Half of that is 1.435. A factory 289 rod length is 5155. We're going to solve for X. So get our handy dandy calculator. We have 1.435 plus 5155. That's 6590. Plus X equals 8.206. So our compression height for a factory 289 piston should be 1.616. And if you look in the catalog, you will generally see that factory piston compression heights were around 1/600. Okay, and you have machining variances in that. You have the fact that your piston is probably going to be down in the hole a little bit, and so your factory pistons are going to be around that height. I like to see pistons at either 0 deck or a little bit hanging out, and that's generally what I aim for. But let's look at why this and this will fit in our 289 block. Again, this is a piston for a Ford 393 Windsor. This is 1/350, okay? This is a rod for our build. It's a scat rod. It's 5/400. So let's look at the math on why this is going to work out. So we will use our block deck height of 8.185. And that's going to equal half our stroke plus our rod length. I don't know why my camera keeps going in and out of focus. Plus our rod length plus our piston compression height. Half stroke, 1.435. This is a 5/400 rod and a 1/350 piston. So when I add all this up, I should get our block height, our deck height, and it should be at 0 deck. So let's do the math. 1.435, 5/400, 1/350. Ta-da! Okay, so let's go over a couple of things and think about this. What that allows me to do is to use a longer rod and a shorter piston, okay? A 1/600 factory piston would be, you know, about, roughly speaking, 5/16 of an inch taller than that. It would be heavier, and it would use a shorter rod. I generally try to use the longest rod and the shortest piston that I can for a factory build within the constraints of safety and longevity. I like pistons. I like longer rods that give, from experience, they give more torque. And as a matter of fact, in past 289 builds in some road race stuff, I have used a 5/700 rod. And it was a small block Chevrolet rod. It took a lot of extra machining, took some specialized bearings, and it took a really short piston to make that work. But it made a whole lot of torque. So if you learn to think outside the box, when you see a piston compression height, this one's listed 1/350, you shouldn't think, oh, well, that's a 393 Windsor piston. Well, it is a 393 Windsor piston because it fits within the constraints of our 9500 deck and a 6200 rod. But this piston doesn't know that it's a 393 Windsor piston. All it knows is it's a piston. And this compression height may work with other rod and stroke combinations. And when you're able to think outside the box, then you can use lighter pistons, you can use longer rods, or you can use different combinations than what you're generally used to thinking about. This calculation also helps when you're dealing with a block that's been decked a lot, and sometimes when we're messing with some old factory blocks, they've been whacked really hard. So, like I said, on an FE, 10170 is factory deck height. I have had FE blocks that came in 10135 because they have been cut so many times. So when I order custom pistons, I have to go through this calculation and to see what compression height and rod length that I can use to make the application work. So in school, they teach you by repetition. So let's go over a couple of different scenarios. Let's work with a 445 FE. 445 FE, we know that the block deck height from the factory is 10170, but generally I have those cut down to 10150 just because of factory tolerances and how horrible they were. We know that a 445 is a 4 1/4 stroke crankshaft. So let's look at a couple of different things. If we used a 6-700 rod, let's do the math. So 10150 minus half of our stroke, which is 4250, so 2125 minus 6-700, that should give us our compression height. So let's do some math here. 10150 minus 2125 minus 6.7, 1.325, and that is a pretty common compression height if you look around at both 445 pistons and 482 pistons. And the 482 pistons are the same compression height because the block is the same deck height, the stroke is the same, and it's typically used with the same rod length. So what happens when we use a 6-800 rod, which is also a little common? What does that do to our piston compression height? 10150 minus 2.125 minus 6.800. That gives us a compression height of 1.225. And this is also a combination that I work with. You don't see that as common in the aftermarket, but this is a viable compression height to use for a thinner ring pack in a higher performance application. All right, one more example. Let's do a 427 Windsor, okay? And factory deck height for an aftermarket block or a factory 351 Windsor block is 9,500. I normally have those cut to 9,490. A 427 Windsor uses a 4-inch stroke. 4-inch stroke, and you can either use a 6-inch rod. You can use a 6-200 rod or a 6-250 rod. So let's do the math on that. If we do our 6-200 rod, half of our stroke is 2 inches. So what would that be? 9,490 minus 6,200 minus 2, 129. So you'll find a lot of aftermarket pistons in the 128 and 129 range. If we use a 6250 rod, what does that do for us? 9,490 minus half of our stroke minus a 6250 rod, 1,240. So you end up with a shorter piston, a longer rod. You could possibly end up with more torque, and you end up with a lighter reciprocating mass hanging on the end of your rod and crankshaft. So win-win for everybody on that. So you may be wondering what kind of wild combinations I have come up with when doing different combinations or thinking outside the box, doing dyno mules, that sort of thing. I'll put up the link to one of my 351 Cleveland dyno mules. Let's do the math for this, and we'll show what worked for this build. So a 351 Cleveland, factory deck height is 9,200, but I usually have those cut to 9,190. Factory stroke for a 351 Cleveland is 3.5 inches, so half of that is 175. I used a 6,400 rod in that engine. Typical factory 351 Cleveland rod length is 5,780 from the factory. Guys typically reach for a 6-inch rod when doing a Cleveland. So I use a rod that's 400 thousandths longer. So what would our piston compression height be? If we do the math, 9,190 minus 175 minus 6.4, inch 040 compression height. That engine made, if you'll look in the video, made about 615 horsepower. I think there was another pull that we didn't do a video on that made 620, but it also made a whole lot of torque, and it had a really light rotating assembly. So one other combination, the 311 cubic inch dyno mule that I'm doing right now, 311 cubic inches. It is a Ford 302 block, and it has been cut to 2,190. It uses a factory 302 stroke, which is 3 inches, so half of that is 1.5. I'm using a 5,700 rod. So what's going to be our compression height on this one? And you guys are going to flip your lid when you see this. Minus 1.5. Minus 5.7. Our compression height is 0.990. So the center line of the wrist pin bore to the top of the crown is less than 1 inch. And I think this is the shortest piston that I've ever used. You see a lot of stroked small block Chevrolet stuff available in a 1-inch compression height, and this is under that. So when you think outside the box, you get to try different things and you find different combinations that work. So when we think outside the box, we can open up whole other ways of doing things when it comes to putting together your rotating assembly. And by doing so, I was able to use this modern Mahle piston with a 1mm, 1mm, 2mm ring pack. It uses a small block Chevrolet wrist pin size instead of a 912 small block Ford size. That gives us more strength in the wrist pin area, and since it's a bigger hole in our piston, it makes our piston lighter. Okay, so I've ended up with this rod piston combination for this 289 build, and that'll make it a really nice addition for the crankcase of our engine and some higher technology parts in the bottom end. All right, guys, I hope that some of that made sense. If you have any questions, put those in the comments area. Enjoy reading your comments, except for the trolls, and it seems like we have a few trolls who want to either be very critical or show what they know. But for everybody else, thank you for your comments. I do appreciate those. And if you have any questions, just let me know, and I'll try to explain something better, maybe in answering your comment or in another video. But thank you for watching. If you haven't already, hit that subscribe button. I hope to have more in this engine building series, just some basic assembly and blueprinting techniques. And again, this is Brent with Lykins Motorsports. I hope you have a good day and a good weekend.